Hey there, it's Jason Gorman from Codemanship with another video update from lockdown. I've been keeping busy. I hope you're busy too. And one of the things I've been busy with, quick shameless plug here, is I've been organizing scheduled online courses in test-driven development. They're happening in May, June and July. So on May the 5th and 6th, there's going to be one for TDD and C#. So if you're a .NET programmer, that's the one for you. In June the 9th and 10th, we're going to be doing one in JavaScript, and on July the 14th and 15th, I think it is, we're going to be doing a 2-day course in Java. This is live instructor-led training. It's online, but it's live in terms of I will be there, you'll be able to interact with me, see what I'm doing, watch me code, I can watch you code, you can ask questions, I can give you pointers. So it's real training, 2-day courses, everything you need to know about TDD, and a ton of hands-on experience with my guidance. Hope you can make it. Twist the boss's arm. For the first one that's happening in May, quick heads up, we're just 3 or 4 days away now from the ticket sales for the early bird price ending. So get in quick if you want to snap up some of those. There'll be a link with details in the description below. Now, talking of test-driven development, what I wanted to talk about today is a technique that I'm a big fan of, and I've been posting over the last few days screencasts illustrating this. Property-based tests. I'm a big fan of property-based testing. What do I mean by property-based testing? Well, let's imagine that we're testing a square root algorithm, and we've been doing TDD, and we've been writing tests that ask questions like, is the square root of 4 2, according to our algorithm? Is the square root of 9 3? So we feed in an input number, and then we also feed into our test an expected output, the expected square root. Now, a property-based test is more general than that. So rather than saying the square root of 9 is 3, the square root of 4 is 2, what we say instead is the square root of any positive number must satisfy this property. If it's the correct answer, it must obey this rule, if you like. For example, the square of a square root must be equal to the original number. The square of any square root must be equal to the original number. So that's a property of a square root. What's the advantage of expressing a test in that kind of way? Well, most of the time there's no advantage, but sometimes the tests that we write when we do TDD are not enough. And that's for the code in our software that is particularly critical, what we call load-bearing code. That's code that's really has to work, has to be very reliable. And you might be thinking, oh, well, that's safety critical code and we don't do any of that. But the reality is, if you analyze most software, some of that code, 5 to 10% usually, is critical in the sense that if it were to fail, it would be a big deal. And therefore, in terms of testing, we might choose to go further. An easy way of going further is to do what's called property-based testing, or generative testing, as some people call it. What generative testing is when rather than me writing a test for the square root of 9, a test for the square root of 3, I write one test and then I generate the test input data, say maybe numbers from 1 to 100, or 1 to 1,000, or 1,000 random numbers, or however I want to generate it, with a small amount of code, generate a list of inputs. And that allows me to get quite mind-boggling amounts of test assurance with relatively little test code. It's a very powerful technique. How do we marry these two techniques, test-driven development and unit testing on the one hand, and property-based testing? And that's what these videos I've been recording over the last few days have been about, is this process, this refactoring process of going from the kind of test you would write if you were doing TDD, the square root of 9 is 3, the square root of 4 is 2, and generative or property-based tests. And it's actually very straightforward. And that's what I like. That's why I'm a big fan of this, because I spent years in the late 90s and early noughties trying to sort of get teams into the whole idea of formal methods. These are very rigorous techniques, mathematical usually, of specifying and then testing software. And they typically involve special languages with weird names like Z and VDM. They often involve special tools that have learning curves that do all sorts of weird and wonderful things with our code, things called model checkers that read the code and invent test cases based on the code, even down to things like proofs of correctness and all that kind of thing. But that never really caught on. That never went mainstream, much to my chagrin. But what has caught on, and in my opinion is just as useful and just as powerful as formal methods, in fact, maybe it is a kind of formal methods, is this thing called property-based testing that uses the same tools that we use for unit testing, but it uses them in a smarter way. Now, to get to that from the tests we write is relatively straightforward. So let's say I've written a bunch of tests for a square root calculator, and then I noticed that all these tests are very similar. They're all different examples of the same behavior. So maybe I would refactor those to remove that duplication from my test code. So that's a win in itself, worth doing it just for that. But refactor all those duplicate tests into a single parameterized test. A parameterized test is just a test, method, or function that accepts parameters for the test data. So we can call it with as many test data sets as we like, as many test cases as we want. So we refactor to a parameterized test. So now we have a lot less test code. And also it's very easy if we want to now to add more test cases because we don't have to write new test methods for each one. But even at that level, if you want to do a lot more tests, let's say 100 tests or even 1,000 test cases, then I'm not going to want to sit there and type out all of those test cases and calculate all of those square roots. That's going to get very laborious. So from that parameterized test, I might then rewrite the assertion in my square root test to assert not that the square root of 4 is 2 or the square root of 9 is 3, but that the square of any square root is equal to the original number, bearing in mind a small margin for error because of floating point shenanigans. So I rewrite my test as a property-based test, a test that asserts a property of any square root if it's correct. And then I can write code that will generate, for example, a range of numbers from 0 to 99 or 0 to 999 at increments of 1 or increments of 0.1 or increments of 0.01, depending on how small I want the gaps to be, how small I need the gaps to be to assure myself that this code is going to be reliable enough in the field. So it's a very, very straightforward process from TDD and unit tests to parameterized tests, and then with a little bit more imagination to property-based tests using tools we have that we already know. We don't need to learn new tools, although there are specialist tools for generating the test data for various languages, but you don't necessarily need them. They do help, but you don't really need them. You can probably figure out how to do these things yourself as well using the tools that you've got. That then opens up a world of possibilities for you for the code that is load bearing in your software, the code that really, really, really has to work. So TDD opens the door to unit tests. Refactoring duplication in unit tests opens the door to parameterized tests. And once you've opened that door, the door is now open to property-based tests, reusing your parameterized tests, that can do as many tests as you need, or as you think you need, to assure yourself that this code really, really, really does work, whether it's 999 times out of 1,000 or 99,999 out of 100,000, or however reliable, 5 nines, 6 nines, 7 nines, 10 nines, however reliable you need it to be. Beyond that, the only restrictions are the availability of hardware and all those kinds of things. But even then, now with open source testing tools, I can stick my JUnit tests or my NUnit tests on the Amazon cloud, and I can throw hardware at my test suites. So maybe I run these critical tests overnight or once an hour or whatever. It's much cheaper and much easier than it used to be. And hardware is getting cheaper and faster all the time. So there you go. TDD towards parameterized tests, and that opens the door towards property-based test, which puts you in a world of high integrity code, just as much as those techniques like formal specification and proofs of correctness did back in the 1990s, when it was, I wouldn't say popular, but some of us had hopes for it, shall we say. Anyway, that's me for today. I hope you're staying safe. Remain indoors, and I'll see you with the next video update.